Now let's just talk about the next question, that is question number 4, which says that AB is a line segment, as you can see, and P is its midpoint. So P is the midpoint of AB. It means that this side is equal to this side. Now furthermore, it says that D and E are the points on the same side of AB, such that BAD is equal to ABE, and further it says that EPA is equal to DPB. You can see that this angle is coming out to be is equal to this angle, and furthermore, as per the question, we know that BAD means this angle is equal to the angle this angle is equal to the angle ABE, means this angle is equal to this angle. And now we have to show that the triangle DAP is actually congruent to the triangle EBP. So let's just start the solution of this one. So first of all, we know that we have a given condition that angle EPA is equal to the angle DPB. We have this condition that EPA is equal to DPB, which is given. So let us suppose if I'm just adding an angle in both of these. So let us suppose add angle EPD on both sides of equation number 1. Let us suppose if I'm adding EPD on both sides. So this is EPA plus EPD, which is equal to DPB plus EPD. So let's just see. First of all, I'm talking about EPA. So this is EPA plus EPD. So here we are talking about a summation of this angle and this angle. So if we are talking about this angle and this angle, so it definitely implies that this is nothing but a whole angle. We can call this a whole angle. We have this EPA, we have this EPA plus of EPD, we have EPD. It means this is nothing but actually forming a whole angle, which is nothing but the angle DPA. Furthermore, if I'm talking about DPB, I'm talking about DPB and I'm adding an angle EPD in it. So I'm just talking about this whole angle. And this whole angle is nothing but the angle EPB. This is angle EPB. So you can see over here, this is nothing but the whole angle, which is nothing but EPB. So hence, I'm just taking the whole angle, which is nothing but EPB, or we can also say that it is nothing but BPE. Now further, let us suppose if I'm calling this as the equation number 2, now we have to prove that the two triangles are congruent. So in the triangle DAP and the triangle EBP, what are the things that we have? So first of all, we know that the very first condition, we know that AP is equal to BP. AP is nothing but is equal to BP, since P is the midpoint, of AB, So furthermore, we know that the angle we have, which is nothing but BAD, we have the angle this angle is nothing but is equal to this angle. We have this angle, which is nothing but is equal to this angle. So let us suppose if I'm calling it as angle 1, I'm calling it as angle 2. So we can say that angle 1 is nothing but is equal to the angle 2. This is given condition. This is nothing but a given condition. And now further we have proved that the angle DPA, DPA is coming out to be is equal to DPA, or we can also say it as APD is actually coming out to be is equal to BPE. We can also say this. So from this second, we can also say that the angle APD is equal to the angle BPE. So we can write it as the angle APD, the angle APD is equal to the angle BPE. So this is from equation number 2. We can also write the equation number 2 as it is, but let us suppose if I am just writing it in such a manner. So now further we know that APD, since APD is equal to BPE, so what can we are getting from this particular condition, that side angle of the two triangles are actually coming out to be equal to each other. So this is the first, this is the second, this is the third thing. So we can say that the triangle DAP is actually congruent to the triangle EBP by SAS, not SAS, by ASA criterion. So we can say that by angle side angle. So this is angle side angle criterion. By ASA congruence rule, we can say that by ASA, this is our angle, this is our side, this is our angle. Angle, side, angle. Furthermore, over here we have this angle, we have this side, we have this angle. So by angle, side, angle congruence, we can say that the two triangles are congruent to each other. So this is the proof for the very first part. And now if the two triangles are congruent to each other, so it definitely implies that AD should be is equal to BE by CPCT. By CPCT, we can say that the sides are also equal of the two triangles. So hence AD is nothing but is equal to BE. So this is all about the question number 4.